8.1 Properties of Tangents. Make sure that you put your name on. Mine's Tara. Make sure that you put your date on to organize your notes. In this new unit, we're going to be talking about circles and the important properties that circles have. Now, a really important idea in a circle is something called a tangent. So I want us to look at this circle right here. So I can draw all kinds of lines. I can draw all kinds of lines through it and over it and under it. I can draw a line that looks like that. I can draw a line that looks like that, that never intersects that circle. So if we see this one, we see two intersection points, one here and one here. This one outside of the circle doesn't have any intersection. What about this one? This one right here. Now, it seems like it kind of touches only once, but when we zoom in even further, we can see that there are actually two intersection points. So I wonder if I can see if I can draw a line that only touches the circle once. Let's see, does that do a better job? Do you know, I see two intersection circles too. It all depends on how you on how much you zoom in. But no matter how hard we try, let me just try to freehand it, something like that. We're kind of touching a few different points. But if we were to live in an absolutely perfect world, we would be able to touch that line only once. So let's take down this really important definition. A tangent is a line that intersects or touches the circle at, it intersects the circle at one point only. And if we're talking about the point of tangency, the point of tangency is the point where the tangent. So again, a tangent is a line that only touches the circle once. So it's a line where that tangent touches the circle. There's something really cool about tangents, and I want to show you this helpful visualization using Geogebra. So if you see this point right here, I'm not trying to do that. There you go. If we see this point right here, we can move it. And when we move it, the angle changes. So you can see that this is actually called a chord because it touches the circle 2 times. But if I bring that point down, you'll see that the angle gets bigger. 41, 42, 43, 44, 45, 46. But what happens when I make that point so close to the other point that it becomes one point? This is something that's a really powerful and important idea. So this turns into 90 degrees. AB, so this line right here, is now perpendicular to the radius, OP or OT, depending on which one, because P and T are now the same point. This is the tangent radius property. T is the point of tangency. So this right here, where T is exactly where the line only touches the circle one time. So I've given you the web address here. There are some questions that you can answer here if this really tickles your fancy. Yeah, go and have fun with that if you want. What I want you guys to get out of this is the tangent radius property. So if we're talking about the tangent radius property, we're saying P, this is the point of tangency. And this whole line right here, this whole line here is the tangent. So a tangent to a circle is perpendicular to the radius at the point of tangency. That is the measure of angle APO. So APO, so this angle right here, just erase off the mess that I made here, is the exact same as OPB. Angle OPB, which is going to be 90 degrees. This is really, really powerful. Okay, so if this is a really important thing to remember. So I don't know, draw a cat. This right here is very important. Okay, this right here, the cat says that that's very important. So let's use what we know about, or let's see if we can apply that tangent radius property. So example 1, point O is the center of the circle, and AB is the tangent to the circle in triangle OAB. Okay, we're learning how to name things here. We kind of did that in the last unit too, but we're going to continue on with that. So AOB here is 63 degrees. We want to find the measure of OBA. So we want to know what this angle is right here. Okay, so let's put in what we know. We know that, I'm just going to change my color just so that you can really see it. This guy right here, if we were to extend this line right here, this is a tangent. And I mean, like, this in and of itself is a tangent because it only touches it once, and if we would extend it, it would still only touch it once. So we know that this right here is a tangent. We know that that's 90 degrees. Well, that's a very powerful thing to realize, because if we want to find the measure of this angle right here, all I do is I say, okay, there are 180 degrees in a circle, and I'm going to subtract off what we know. So we know that we have 63 degrees, but we also know this angle right here. We know that that is going to be 90. So the measure of angle OBA equals 180 minus 63 minus 90. So we know that it's 27 degrees, because this angle plus this angle plus this angle has to equal 180. Okay, that's great. Let's move on to the next question here. So example number 2. Point O is the center of the circle, and CD is a tangent to the circle. So as soon as we know that, we can say, oh, okay, I know that that's 90 degrees here. CD is 15 centimeters, yeah, and OD is 20 centimeters, yeah. Determine the length of the radius OC. Give the answer to the nearest tenth, so that's 1 decimal place. Okay, so what I want you to do is I want you to shake off the dust from the Pythagorean Theorem, because right here, folks, we have a right angle triangle. We're going to be actually using the Pythagorean Theorem quite a bit. So we need the Pythag, and we know the hypotenuse. We know that what the length is we know the length that's opposite of the hypotenuse. So we're going to use the subtraction. So if I were to say this, I would say b squared equals c squared minus a squared, where c squared is always going to be the hypotenuse. Okay, so I'm going to say this is c, and this is a, and this is b, my unknown. So now, like a good little math student, I'm going to substitute what the actual values, what the actual letters are here. So I'm going to say this is OC squared equals OD squared minus CD squared. OC, that's what we want to find, equals C, which is OD, okay, minus CD squared. So I'm just going to substitute in the values that I know for OD and CD. So OC squared equals 20 squared minus 15 squared. OC squared equals 400 minus 225. 400 minus 225 is going to be 175. Now, in order to solve for OC, I'm going to square root both sides. So OC equals 13.2 centimeters. And we're done. Last but not least, let's look at more of a real world problem here. So an airplane, A, is cruising with an altitude of 9,000 meters. A cross-section of the Earth is a circle with a radius approximately 64,000 kilometers. So if this is our Earth, the radius of the Earth is approximately 6,400 kilometers. A passenger wonders how far she is from a point H on the horizon. So when she's looking out her window here, she wants to know how far it is to that point right there. She calculates the distance to the nearest kilometer. Now, what's very helpful is that we have kind of like a visualization of it. So here's the Earth, and here's the little airplane. We're gonna say that this one right here is gonna be E. We're gonna call that the center of the Earth, E. And when we're looking out the window to this black dot, we're actually looking at this right here. Okay, so that is actually a very helpful visualization that this is right from the textbook gives us. So if I were to go like this, I know that this right here is going to be a right angle, because this right here is this line right here is a tangent. That's a really important key thing. I want to figure out how the length of EA is, because we have 6,400 kilometers, or 6,400 kilometers, and we have 9,000 meters. So it's important to know that 9,000 meters is just 9 kilometers. We kind of have to get into the same units. So the length of AE is going to be 6,400, sorry if I said 64,000 before, plus 9. So AE is going to be 6,409 kilometers. We did just create this right here, but we said that the radius of the Earth is 6,400 kilometers. So guess what, folks? This is still a radius. This is still a radius. We know that anything from the center to the edge of the circle is going to be 6,400 kilometers. So what we want to do is we want to solve for AH. We have the hypotenuse, so we're going to use subtraction. So we're using the Pythag, and we're going to use subtraction. I'm going to call this my C, I'm going to call this my B, and I'm going to call this my A. Okay, so we're going to say B squared equals C squared minus A squared. HA squared equals AE squared minus HE squared. All I'm saying is if I want to solve for this length here, I have to take the hypotenuse, okay, which is going to be my AE, it's the longest one, minus HE. So AH squared, I'm going to substitute the numbers in, is going to be 6,409 squared minus 6,400 squared. Now I'm going to actually write down the numbers, and they're kind of big. So that's going to be 41,075,281 minus 40,960,000. So when I do that subtraction, HA squared is going to be 115,800 and 281. When I take the square root of both sides, I get HA equaling 339.50. Oh, it's 530. But the question says to the nearest kilometer. So I'm going to say, okay, so HA equals 3, and because it's 39 and this is bigger than, this is 5 or above, we're going to say 340 kilometers. And we're done. So the distance between the airplane and the point on the horizon is 340 kilometers. Okay, so let's write down a summary here before you move on to the homework pieces. So in summary, tangents touch the circle only once. They make a 90-degree angle with the radius at the point of tangency. We can use this helpful information to solve for other parts of the circle and lines surrounding it. Excellent.